Hi there, my name is Sandeep Arora. I've been working on AI for the past 12 years. I've written a book on AI and I have 4 NVIDIA certifications. So I do a lot of work on AI. Today, I want to talk to you about large language model customization. Okay, so large language models have been trained on massive amounts of data. They have world knowledge. Uh, some are multimodal. They understand human language. They can do language translations, but they might not know the domain of your business. They might not understand the language of your business. They might not know the nuances. So, for example, if you work in the legal area or healthcare, they might not know that detail, they might not have that detailed specific business knowledge. Now, to use these large language models for your business, you might have to customize them, okay? So that you can embed them into your workflows, or you can create chatbots for your workers. That customization is going to be important. And today I'm going to talk to you about the different ways by which you can take a large language model and customize it, train it for your business domain, for your task specific behavior. So let's get started. All right, so let's see this works fast. All right, so model customization. We'll talk about the different ways you can do it. Okay, as I said, model fine tuning is the process of taking a pre-trained model and customizing it on your business knowledge for your specific tasks so that it is accurate, it is smarter for your business, it doesn't hallucinate, and it can be used with high accuracy for your business to assist your workers. So I'm going to talk about these 4 ways: supervised fine-tuning, direct preference optimization, reinforcement fine-tuning, and distillation. Okay. So supervised fine-tuning is the simplest. Okay. This is where you take a data set of input and outputs. Basically, humans are going to collect a data set of high quality input output pairs, prompt response pairs. Okay, so this is exactly how you want the model to behave if this input is given. Okay, so humans are going to collect high quality question and answers related to your business domain, related to your task. Okay, once that data is collected, you will train the large language model on this data. Okay, on this data. So what happens is the model learns your business domain, it gets knowledge about your business, uh, it gets better at your specific task. So that's what exactly happens. And once it's fine tuned, you can use it in your workflows, or you can use it for chatbot assistants for your workers. Now, the other use case why supervised fine tuning is used is for cost saving. So if you have very large prompts, right, uh, you can basically train the model on those large prompts and expected responses, so that after training you don't have to send those long prompts and you can have cost savings. Okay, so that's another way to use it. uh, and also it's used for customizing response structure. So let's say you're in a medical field or legal field, and small difference in language can make a big difference. So you can train it on, structured responses. So I hope that is clear. Let's go to the next one. Okay, direct preference optimization. Here, the way it's done is humans collect a data set of input and output pairs, and the output is going to be a good output and a bad output. Okay, with the ranking. Okay, so you're going to say, hey, this is the type of outputs I prefer, and this output I don't prefer. Okay, so essentially you are teaching a model human preferences. Okay, you want, and it's more subjective kind of alignment. You are training a model to align with your brand tone. You are training a model human subjective preferences. Getting it? So that's that, right? So once you have this data, right? Once you have this data, right? You can take a base model and fine tune it based on this data so that it understands that it needs to output in this manner. Okay, whether it is brand tone or politeness or business nuances, DPO assists, it helps in that. Okay, so that's DPO. Let's move to the next one. Okay, let's talk about reinforcement fine-tuning. So RLHF is a framework where you want to teach a model human preferences, okay, by combining human feedback and a technique called PPO. All right. So essentially, you are trying to teach a model complex business rules, complex human preferences, and this is done in in areas where you want high accuracy, like medical, legal. Also, it's used to teach models reasoning. Okay, and RLHF is the technique which has gotten us, which OpenAI uses to train their reasoning models. All right, so reinforcement fine-tuning is a two-step process. The first step is you have to build a reward model. So the way you do it is you take a base model and you ask the base model to generate responses for your prompt data set, and you ask it to generate 2 or 3 responses, and then humans are gonna rank those responses. I give this response the highest points, this is the second highest, this is the third highest. So, and then you train the base model on those human preferences, and what comes out is a reward model. Okay, so the reward model understands it is trained on the ranking based on humans. Step 2 is where you actually fine tune the base model based on the reward model. Okay, so you have your data set of prompts, and the reward model is gonna rank the responses generated by the base model using a technique called PPO, and it's gonna be trained. And step 2 is exactly how it's trained using the reward model. So DPO was also about training the model on human preferences, but RLHF is about complex use cases where high accuracy is needed, where reasoning is needed, where details matter. All right, so let's move to the next one. Destination. Okay, here what we are doing is you have a large model. Okay, it is accurate, you like it, but but it's very expensive. Okay, it's very expensive to infer, it's expensive to deploy. You want to deploy it on edges, right? So what you do is you take a large model, you ask it to generate input output data. Okay, this data is fine, okay, but it's being generated by a large language model. which is again, it's we think of it as a teacher model, and the large language model cannot be deployed on edges. It is expensive to infer. It has a high TCO. So you use a large language model to generate synthetic data, and this data, you like it. Okay, you like it's well suited for your task. It is okay for your business, and then you use this data to train a small model. Okay, now the small model is a student model, and the benefit is it learns this business. Plus, okay, of course, it is low cost to infer. You can deploy it on an edge. It has low latency, things like that, right? So the large step one, as I said, the large high performing is a teacher model. You generate responses for a wide variety of prompts, and then you use that as an input to train the smaller, the small large language model. So that's it. I hope you enjoyed it. I'm gonna see you again soon. Take care. Bye.